Now that we've talked about what a surd is, we're going to look at how to simplify some of them. Before we do this though, it's good to talk about our square numbers. The square numbers are what we get by squaring different numbers. So for example, 1 squared is 1, 2 squared is 4. Remember, we're doing this by multiplying the number by itself. So in other words, 1 squared means 1 times 1 equal to 1. 2 squared means 2 times 2 equal to 4. 3 squared is 3 times 3 equal to 9. And we could keep going up like this. 4 squared is going to be 16. 5 squared is going to be 25. 6 squared, 36. 7 squared, 49. 8 squared, 64, and so on. Now these numbers that we get here I wrote 44, and of course I should have written 64. But these numbers that I've highlighted in red here are what we call square numbers. And we're interested in them because if we take the square root of any of these numbers, because of where they come from, we are going to get a whole number answer. So if we ever see a square root of 64, for example, we know that that's going to be 8. If we see a square root of 49, we're going to get 7. And when we're simplifying our surds here, we're going to be interested in finding these numbers pop up because they're going to allow us to simplify our surds nicely. So let's have a look at this first problem here. The square root of 12. Now if you were to key that into your calculator, you'd see pretty quickly that you're going to get a fairly horrible decimal answer. It doesn't have a whole number answer. It's not a surd. Another way of knowing that, if you look at your list of square numbers, 12 doesn't appear. So it's not going to be a nice answer. But we do want to be able to tidy it up. So what we're going to do is we're going to look at the number 12 and we're going to think about how else can I write 12 as a product of two numbers or as two numbers multiplied together. And you've got a few choices with 12. You could write 12 as 2 times 6, or you could write it as 4 times 3. This is actually going to be my better choice. And the reason I want to choose this one is it's got this lovely 4 in it. And if you look up here, 4 is in my list of square numbers. So what I'm going to do is I'm actually going to rewrite this square root of 12 as the square root of 4 times 3. And a lot of maths is all about this. It's about taking one thing and then writing it in a slightly different form so that we can do something nice with it. And the something nice that we're about to do is break this square root up, and I'm going to treat each part separately. This is one of the rules of surds, that if I've got something like this, the square root of two numbers multiplied together, I can take the square root of each of them and then multiply that together. So I can rewrite the square root of 4 times 3 as the square root of 4 multiplied by the square root of 3. And if we have a look here, since 4 is my square number, I know that the square root of 4 is just going to be 2. And the square root of 3, it's not in the square numbers, so I can just leave it as it is. And often when we're working with algebra, we like to leave multiplication signs out just to tidy things up, so it's a little less crowded. And I get 2 square root of 3. And we'd sometimes read this 2 root 3. So now we've simplified the surd, the square root of 12. Let's move on to our next example, the square root of 125. If we think about 125, we've got a few more options in terms of how we can deal with this one. But if I have a look there, we notice it ends in a 5, so that tells me it's a multiple of 5. Okay, I can probably divide this by 5, and that would be pretty nice. And if you actually work that out, you can find out that 125 is equal to 5 times 25. Now that's particularly nice because 25, once again, is in my list of square numbers. So I know that the square root of 25 is going to be equal to 5. So to simplify this surd, I'm going to make this equal to 5 times 25 with the square root over all of it. And just as before, I can split this surd up into the square root of 5 times the square root of 25. Now let's have a look here. Square root of 25 we know is equal to 5. This square root of 5, we can't simplify that because it's not a square number. And I've got here the square root of 5 times 5. I could leave the multiplication out, okay, and be left with this. And that's perfectly acceptable, okay, you're allowed to write it that way, but it's not the way that we prefer to write it in maths. Okay, the convention here is usually we put the number that doesn't have a square root over it first. So we can actually just swap the order of those and put it in this order, and that just looks a bit neater, it's a bit more consistent, keeps it the same as over here. You're allowed to swap that order because we know that when we are multiplying two things, we can change the order. Okay, you can check that, 2 times 3, that's the same as 3 times 2. You can swap the order. So here we can swap the order of these two things and write it as 5 root 5. Alright, one more example here. This one is the square root of 17 over 100. Now, with a division like this, we're allowed to split it up in exactly the same way as we split up this kind of thing before. So if I've got the square root of a whole fraction, I can rewrite that as the square root of 17 divided by the square root of 100. And again, this is where knowing your multiplication tables comes in. If you take 100, we know that that is a square number and it's the result of 10 times 10. Okay, or 10 squared. So the square root of 100 is straight away just going to simplify to 10. And I'm going to get the square root of 17 divided by 10. And this actually isn't going to be able to go any simpler because we know that 17 is a prime number. That means it doesn't have any numbers that multiply to give it at all. It's definitely not going to be in my list of square numbers. So that's how we simplify surds.